Have you ever heard of hyperbolic functions and maybe you wonder what they are? Well, hyperbolic functions are just functions that are similar to trigonometric functions, but these functions are expressed in terms of what exponential functions. I just want to elaborate a few things about the hyperbolic functions. So we have the same way we have ratios in trig, like sine, cosine. Even here we have them, but the way you pronounce them is a little bit different. Okay. All right. So the first one is shine. This one is pronounced as a shine. You pronounce this one as shine. Okay. You pronounce it as what? Shine. So shine x in this case is just equal to e to the power x minus e to the power negative x over 2. That is shine x. All right. Number 2, we have cosh. This one is pronounced as cosh. You pronounce this one as cosh. All right. So we have cosh x is just equal to e to the power x plus e to the power negative x over 2. You can see the difference between these two, just a sign in the middle, isn't it? Exactly. Okay, so that is for sine, that is for cosh. Well, let's look at the in terms of tan. All right. Okay, so in terms of tan, we pronounce it as tank or than. All right, so we have tan x like this. All right. Okay, like this. You see now? This one is pronounced as tank, or you can pronounce this one as than. This is how you pronounce it. And you know that when you go back to trigonometry, we said tan theta is just equal to what? Sine theta over cos theta, right? Even here it's the same. You see? Shine. It is shine x over cos what? X. Which, when you look at this, since we know what shine x is as that one, and we know what cos x is, this one will just take us to, so we have, this is what we're going to have. Shine x is e x minus e tefio over what? 2. Since we are dividing, we just cross multiply. 2 goes there. Then we introduce this one here, which is e x plus e negative x. You can see that and that cancel. This is they can't cancel because there's a sign, there's a difference in sign in the middle. So we get e to the power x minus e to the power negative x over e to the power x plus e to the power negative x. This is for than x. This one here, you see 9. Then we can also find for sec, all right, but sec is pronounced as sech or shek. So shek x, this one you pronounce it as shek, or you can say sech. It's given by, how do we find sec in normal trig? Sec is 1 over cos, right? So we're going to say it's 1 over what? Cos x, which we know will give us 1 over, what is cos? All right, what is cos? Cos is just ex plus e minus x over 2, which when we reciprocate, we just end up giving us 2 on top over ex plus e negative what? X as the answer for quotient. Okay, we move on. We look at another one. This is our what? Our fourth, right? Let's go to our fifth. Our fifth is the issue of cosec in trig, but this one we pronounce as cosec. All right. So if you want, you can say cosec or cosec. So this one you pronounce it as kosheki. All right, or you can say cosec, depending. All right, and it is given by, you know that from trigonometry, we said cosec is just 1 over sine theta, right? So even here it will just be 1 over shiny x. But we know what shine x is. Shine x is e to the power what? X minus e to the power negative x over 2. Reciprocating, this one just gives us what? 2 over ex minus e negative x. This is for cosec x. The last one is, cot theta. Tefio. In terms of trig, we have cot, right? Even here we have cos x. It is pronounced as coth. You pronounce it as coth. All right. So what is cos x? Cos x, remember that it just cot from trigonometry, just 1 over tan what? X, right? From the trig. Cot and tan, they're inverse of each other. So even here it will be 1 over tan x. So, but we know what tan x is, isn't it? So tan x, we found tan x somewhere here. Where? Here. This one here. All right. So we're just going to say 1 over that. So this is 1 over e x minus e negative x over e x plus e negative x. Because of 1 here, we reciprocate everything, which will lead us to ex plus e minus that over, we have ex minus e negative what? X. Like that. This one is for cos x. Of course, you can rationalize these and come up with simplified versions of them. Nevertheless, this is what you need to know about hyperbolic functions. The rest is just a matter of graphs and calculations, okay, and identities.